everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In last session, we have seen about shortest job first CPU scheduling algorithms in preemptive and non-preemptive. In this session, we are going to see about priority CPU scheduling algorithm. Let us see the overview of the presentation. So in this presentation, we are going to see about priority CPU scheduling algorithm with preemptive and non-preemptive methods. So let us see the definition of priority CPU scheduling algorithm. In priority CPU scheduling algorithm, it is a non-preemptive algorithm and one of the most common scheduling algorithms in batch systems. Batch systems is nothing but it is one of the type of operating system. Each process is arrived with the first arrival time. So, which is having less arrival time process will be executed first. So, if two processes have same arrival time, then compare the priorities with the highest process first. So, compare with the priorities means in the previous sessions we have seen about the arrival times and burst times. When compared to in SJF, we have seen the lowest burst time will be executed first. So, in this, if the arrival times are same, we need to compare with the priorities. So, priorities will be given. So, based on that priority, we need to execute our process. So, if two processes have same priority, then compared to process numbers. So, again, if the two processes having same priorities, then we need to compare with the process numbers, nothing but P1, P2. So, which is having less number, that will be executed first. That is what about priority. This process is repeated when while all process gets executed. So, this process is repeated until and unless all the process gets executed. So, next, how you are going to implement? First, input the process with their arrival time, burst time and priority. So, in previous we have seen about arrival time, burst time. In this we need to compare with priority also. First, process will be scheduled and which is having the lowest arrival time. If two are processes with having lowest arrival time, then you can compare with higher priority will be scheduled first. So, if the both are having lowest arrival times, then we need to compare with the priority. So, which is having higher priority will be scheduled first. That is what about this priority scheduling algorithm. So, now further processes will be scheduled according to the arrival time and priority of the process. So, in further the process which are scheduled according to the arrival times and priority will be used for their higher values. That is what based on the priority of their values. Here we are assuming that lower priority number having highest priority. So, nothing but the number which is having low priority number that gets higher priority. The number is which is least that gets the higher priority. That is what about this priority algorithm. If two processes priority are same, then sort according to the process number. So, if the two priorities, suppose P1 and P2 has the same priorities with 0, 0. So, then you need to compare with priorities numbers. So, P1, P2, which is having least, so P1. So, we need to sort according to P1. So, P1 will be executed first. Next, let us start our non-preemptive method using this priority scheduling algorithm. In the non-preemptive priority scheduling algorithm, the processes are scheduled according to the priority number assigned to them. So, it is scheduled according to the priority that can be assigned by their priorities. Once the process gets scheduled, it will run till the completion. So, once the process starts its execution, then it starts its compilation. Generally, the lower priority gets the highest priority of the process. Nothing but the priority which is low, it gets highest priority. That is what about this algorithm. So, consider the following table with the arrival time, burst time and priority. So, we need to find all these 5 processes based on the priority. So, let us start our problem in non-preemptive method. So, first priority, then process, then arrival time, then burst time, then completion time, then turnaround time, and then waiting time. So these are the solutions for this problem. So P1, P2, P3, P4, P5. So what are the arrivals times? 0, 5, 12, 2, 9. What is the burst time? 11, 28, 10, 16. So priority is 2, 0, 3, 1, 4. 2, 0, 3, 1, 4. So based on this priority, arrival time, burst time, we need to solve our Gantt chart. Gantt chart and ready queue. So as all you know, our Gantt chart arrival starts from 0. Arrival time starts with 0. So the process which is having arrival time 0, who is ready from all the 5 processes? P1 is ready. So in this you may get doubt. This problem is based on priority, so we need to take the priority numbers, you may get the doubt. So according to our Gantt chart, the arrival time with 0 will be executed first. So we need to compare with the arrival time, then with which is having arrival time 0, that will be executed first. So P1 will be executed first. With P1, with the burst time is 11. So 0 to 11, which all our processes are available? P1 is completed. So P2, P4, P5. So P2, P4, P5. So now again you may get doubt. So now how we are going to compare with the priority? So the number which is having low priority gets compilation first, means gets the CPU first for the execution. So which is having least priority? P2, P3 and P5 are ready. So which is having low priority? So P2 is having low priority. Why? Because it is having 0 priority. So P2 is executed first. So P2 with the burst time is 28. So we need to add 28. 11 plus 28 is 39. So 39. So now again we need to check which processes are ready. All are ready. So P2, P1 is completed. So now we need to check the priority also. Which is having low priority? 0 is P1 is completed and P2 is completed. Next P3, P4, P5 are waiting. So which is having low priority? P4. So P4 will be executed first. With the burst time is 10. So P4, 10 plus 39 is 49. Next, this also completed. So now which is having low priority? 3 or 4. So P3, then after P5. So P3. What is the burst time of P3? 2. 49 plus 2 is 51. So what is remaining last in the ready queue? P5. So with the burst time is 16. So 51 plus 16 is 67. So 67. P5 is also completed. This is what about Gantt chart using priority. So how when the process P1 completes its execution at 11, then P2 39, then P3 51, then P4 49, then P5 67. So what is our turnaround time formula? CT minus AT. So 11 minus 0 is 11, 39 minus 5 is 34, 51 minus 12, 39, then 49 minus 2 is 47, 67 minus 9 is so 58. This is what about turnaround time. So waiting time formula is turnaround time minus burst time. So 11 minus 11 is 0, 34 minus 28. So 14 minus 8, 6. So 6. 39 minus 2 is 37. 47 minus 10 is 37. Next 58 minus 16, 2, 4, 42. This is what about turnaround time and waiting time. So now I need the average of waiting time. What is the average of waiting time? Total of waiting time by number of processes. So what is the total? 37 is 74 plus 6, 80, 42. So 122. So 122 divided by 5. So 5 ones are 5 twos are 10, 2 remains, 5 fours are. So remaining is 24.2%. This is what average of waiting time. So next we are going to see about preemptive priority scheduling algorithm. In this preemptive priority scheduling algorithm, at the time of arrival of a process in the ready queue, its priority is compared with the priority of other processes. So it is based on the priority, it is comparing with other priorities present in the ready queue. So which processes are present, that is compared on based on their priorities, as well as with one of which is being executed by CPU at that point of time. So when it is executed by CPU, that point of time, the which is having low priority, that gets executed first. So the process which are waiting in the ready queue, that can be executed by CPU once they are arrived. The one with the highest priority among all available processes will be given CPU next. So the one is present. Suppose P1 is existing, after the P2, P3 execution only P1 will be executed. So after it is executed by the CPU next. In this process, in this program, we have both options, whether they consider in highest priority or highest number, or highest priority or lowest number as highest priority. So highest number may consider as highest priority, or else lowest number is considered as highest priority. That is based on your option. So consider the following table with the arrival time, burst time, priority of 5 processes. So in the previous we have seen about non-preemptive based on priorities. In this we need to check with the priorities and burst time, reducing preempted by taking the time quantum with 2. So priority, process, arrival time, burst time, completion time, turnaround time and waiting time. So processes P1, P2, P3, P4 and P5. Next 0, 5, 12, 2, 9. 0. So these are not priorities values. So 0, 5, 12, 2, 9. 0, 5, 12, 2, 9. Next 11, 28, 2, 10, 16. 11, 28, 2, 10, 16. Next 2, 0, 3, 1, 4. 2, 0, 3, 1, 4. So based on these values, we need to start our Gantt chart. Gantt chart, and who are waiting the ready queue, in ready queue, who are waiting for the CPU. So our Gantt chart starts from 0. So now check which process is under 0 with the arrival time. So P1 is ready. So with the burst time is 11. So here I am taking time quantum as 2. So you need to reduce the value with 2. So 11 minus 2 is how much? 9. So take P1 and here we need to write 2. Why? Because the time quantum is 2. So 0 to 2, which are waiting for the CPU? So 0 to 2 we need to check only arrival time. So 0, 2. So P1 and P4. In this case, we need to check the priorities also. So P4 is having 1 priority and P1 is having 2 priority. So low in number gets highest priority. So 0 to 2, which is available? P4 is executed first, then P1. So P4, what is the burst time? 10. So 10 minus 2 remaining is 8. So 2 plus 2 is 4. So now 0 to 4, which all our processes are ready for the execution check? 0 and 2. Again P1 and P4 is only ready. Why? Because we need to check up to 4. So which is having lowest priority? Again P4. Then P4 again, then P1. So P1 with the burst time is 9. So 9 minus 2 is remaining is 7. So P1, 4 plus 2 is 6. So now 0 to 6, which processes are ready? P1, P2, P4. So P1, P4, P1 are existing. So we need to take the lowest burst time. So which is having lowest burst time? P1, P2, P4. So P2 is having low priority. So P2 first, then after P1, then P4 and then P1. So these are having low priorities. So next P4 is arriving next. So P4 with the burst time is what? 8. 8 minus 2 remaining is 6. So 6 plus 2 is 8. So P4 is also completed. Next P1. P1 is waiting. So P1 is waiting with the how much? Burst time is 7. So 7 minus 2 is 7, 6. So 5. So 8 plus 2 is 10. So now to 10, sorry. So as here P4 is arrived, we need to check until 8. So now who is available under 0 to 8? P1, P2 and P4. Why? Because P5 and P3 are existing out of 8. So we need not consider that value. So who is having low priority? Again P2, then again P4, then P1. So next P4 after which is waiting for the CPU? P1. So P1. So we need to do minus 7, 8 plus 2 is 10. So 5 is remaining. So next P2. P2 with the burst time is 28. So 28 minus 2 is remaining, 24 is remaining. So we need to take 10 plus 2 is 12. So now from 8 to 12, which processes are ready? Next P5 is ready, P3. All the processes are ready. So now we need to check according to the priorities which arrives first. So P1 first P2 is arriving, then P4 is arriving, and next P2, P4, and next P1, and next P3, and then P5. These all are now waiting for the CPU. So let's start again. P2 after which is ready? P4. So P4 is ready with the burst time 16. So 16 minus 2 is remaining 14. So 12 plus 2 is 14. Next P1 with the burst time 5 is remaining here. 3 is left. So P1 14 plus 2 is 16. P1 completed. So next which is waiting for the CPU? P2. So P2 with the burst time is 24. We need to minus 22 is remaining. So 16 plus 2 is 18. Next P4. P4 is having burst time 6. Reduce the value, remaining is 4. So P4, now 18 plus 2 is 20. And next P1 is waiting. P1 with the burst time 3. So 1 is remaining. So 22. Next P2 is waiting. With the burst time is 22. 22 minus 2 is 20. Still 20 is remaining. So 24. Next is waiting. P4 is waiting. With the burst time is 14. So we need to reduce the value. 12 is remaining. So 24 plus 2 is 26. Next, which is remaining? P1. So P1 with the value of 1. So P1 completes its execution with 27. Next, P3. P3 is waiting for the value of 2. So P3 is also completed. So 27 plus 2 is 29. Next, P4, P2, P4, P5 are remaining. So we need to calculate directly. So P5, so 12. So 29 plus 12 is, so P1 completes by 41. Next, P5 completed, then we take P2, P4. So P2 and then P4. So P2 with the burst time is 20. So 41 plus 20 is 61. So P2 completes its execution by 61. Then P4 is remaining with 4. So P4, 61 plus 4 is 65. So this is what about the Gantt chart. So now completion time. So now CET completes, P1 completes its execution by 27. Next P2 by 61. Then next P3 29. And next P4 65. P5 41. So these are the completion values of processes. So next turnaround time formula is CT minus completion time minus arrival time. So 27 minus 0 is 27. 61 minus 5 is 66. And next 29 minus 12, 17. Again 65 minus 2 is 63. 41 minus 9 is 32. So what is the waiting time? Turnaround time minus burst time. So 27 minus 11 is 16 and 66 minus 28 is 38. Again 17 minus 2 is 15. 63 minus 10 is 53. 32 minus 16 is 24. So we need to calculate our average waiting time. Average waiting time is total waiting time by number of processes. So total waiting time is 146 by 5. So 5 ones are 5 twos are 10, 4 is remaining, 5 nines are 45, 1 is remaining. So 0.52s are 10. So 29.2% of waiting time. So in this session we have discussed about priority scheduling algorithms, used by preemptive method and non-preemptive method. So if you have any doubts, you can comment. Thank you.